Assalamu alaikum. Our topic is Introduction to DSP. DSP Digital Signal Processing. Before knowing DSP, we should know what is a signal. As definition suggests, signal is a physical quantity that changes with time, frequency, and temperature. Now let's try to implement this definition physically. We have traffic signal installed everywhere. Imagine a traffic signal showing a red light only. Will we count it as a signal? Definitely no. A signal is a name of change in a physical quantity. Red light suggests us to stop, yellow tells us to get ready, green tells us to move. So here lights are changing with respect to time and thus they are representing a signal. Now have a look at the second definition. A signal is a function of one or more independent variable that carries same information to represent a physical phenomena. Here in traffic signal example we have only one independent variable which is time. We can have more than one independent variables. For example, we can consider example of weather. Weather changes with both time and temperature, so depending on two independent quantities, time and temperature. In short, a signal is a name of change in a physical quantity with respect to some parameter, for example time, temperature or frequency, etc. Now let's come to the digital part. Why we use digital signals in DSP? We use digital signals because they are discrete, they are finite. Finite means a limited set of values. Digital signals are not, don't give us as exact results as analog, but they are easier to work with. For example, in an analog clock, we have to follow the needle simultaneously to check the time. However, in digital clock, digital time is given, and there is no need to follow the needles. So in short, we use digital signals because they are easy to work with and they have a finite set of values, which means they have limited set of values. What is processing? Transformation via algorithm or technique that converts from one form to another in a modified version of original signal to achieve a desirable result. We use different set of techniques, coding, algorithm to get our desirable result. For example, we are given different temperatures and we have to figure out the max one. So using an algorithm, we can figure out the max. In another example, we have to amplify a signal using certain set of techniques. So using a techniques or algorithm, we can amplify it and get our desirable result. So on a whole, what DSP is? DSP are the set of techniques which we process on digital signals to make things easier. We have two time of domain analysis in this, time domain analysis and frequency domain analysis. Let's have a look at the importance and advantages of DSP. First, let's have a look at compression. Data is compressed so that communication or traveling of data become easier. We have example here. For example, we have three frame size of photos, 300 cross 400 frame size, and we have to send it from source to destination with data rate of 1 kilobytes per second. So we have to calculate the time as the image all the images reaches from source to destination. We know the formula speed, distance over speed, and we know the data rate as well as the frame size. So we divide frame size over data rate to get the time period. We get 360 seconds. In adjustment in the next two images, we have a sun and a person standing, and because of the sun and the man, the resolutions have changed. So in spite of sending the whole image again, using compression technique, we can send up a portion of it by using delta modulation. So the frame size becomes 1,20,000 plus 15,000 plus 15,000 and divided by data rate, which is 10,000. So we get time frame of 150 seconds. In the third case also, we can also reduce the bytes to 10 times, and by reducing the bytes to 10 times we get the total time 15 seconds. So here we have learned that by using compression, the time period of sending images and communication can become much faster by using compression. Now let's have a look at another example of DSP, which is sorting. Sorting is any process of arranging items systematically. We can see in this row we have unsorted data which is not arranged in any order. Now if we have to find a data of 0, 6 and 15 in this unsymmetrical or unsorted data, we find 0, 6 as the best case because it's present on the first number and we find it in the first iteration. But what happens when we find 15? We find it in the 14th iteration. This is limited data, but if we have suppose a data of 9,000 data 9,000 this data is this data is limited, but let's suppose we have million numbers given and we have to find any one of them. Now what will happen if we find it in the same way one by one? Then we have million numbers given and we have to find any one of them. Now what will happen if we find it in the same way one by one? Then then we will waste a lot of time in doing this. So there must be a way or technique to sort it out so that we can find data easier. DSP allow us to use such a technique known as binary search. In binary search, we have considered the similar data and we have arranged it in the ascending order. What it does, it takes the mid of the whole data, which is 21 here, then it divides the data into two blocks. So for example, one block is from 23 to 100 and another block is 03 to 18. Now we have two domains here, which is one is greater than 21 and another is lesser than 21. So we have to find 06, which is lesser than 21. So we have to neglect this whole block and we will consider only this block. Now we have only one block left, which is the upper one. What it does, it chooses the mid of the upper block, which is 09. Then we have to check whether 06, either 06 greater than 09 or lesser than 09. We know that 06 is lesser than 09, so it's also neglect the lower one. This block is neglected now and this one is selected. So then it again takes the mid, which is 04. And then now we are left with only 06, which is our answer, required answer. Similar the case with the searching 15. If we have to search 15, it consider the mid first, then we consider 09, and we check whether 15 is greater than 09 or lesser than 09. 15 is, we know that greater than 09, so we consider the lower block and neglect the upper block, and then we select the mid and we get the 15. So by using binary search, data can be more easily found, and number of iterations can also be decreased. DSP allows us to manage our data in a more easier way. Worst case of number of iterations can be found by using formula log to n, where n is the number of iterations. Then another example of DSP: when a singer sings a song, the sound quality is not that great that we listen on our cell phones or on our headphones. The sound goes through a lot of procedure, lot of techniques, DSP techniques, in through an auto tuner, so that the quality becomes great and it becomes easy to listen.